Hello and welcome to my session at the SAP online track about serverless side-by-side extensions with Azure Durable Functions, or how it is when stateful meets stateless. Within the next 50 minutes, I would like to give you some insight about an option that you have to extend your SAP system making use of serverless offerings on the Microsoft Azure cloud. Before I start, I would like to introduce myself very shortly. My name is Christian Lechner, and I'm heading the Microsoft Azure team at a company called Minisphere, which is the innovation lab of MSG. I am not originally, having my roots within Microsoft, but I'm coming from the SAP ecosystem, and I've been working in this ecosystem since 2005. I'm kind of active in the SAP community, and right since the start, my focus topic was extensibility. So how could I extend SAP systems in order to fit the requirements of customers? I started in the ABAP space, and within the last years and the new options that you have within the SAP ecosystem, I started more to dig into the cloud native development and now focus on serverless development. And if you want to reach out to me, here's my Twitter handle. That's probably the best way to get in touch with me. Okay, so enough about me. Let's start with the basic questions that you might have when it comes to Azure Functions, right? Why should we care about all these Microsoft thingies when we are at an SAP online track? So why should I extend my SAP system with the offerings of Microsoft? Well, at Sapphire 2019, there was an announcement of the SAP Embrace project, which should help the customers to adopt S4 and adopt the clouds in order to make the intelligent enterprise reality and to drive innovation. And at the end of last year, this offering kind of, manifested itself in a very close partnership between SAP and Microsoft, bringing together the portfolio of both companies of SAP with all the S4 systems, SAP Cloud Platform, and so on, and Microsoft with Microsoft Azure, but also with all the Office portfolio, SharePoint, and so on and so forth. And now, bringing those two portfolios together, you have a lot of options that you can do now as a customer or as a partner. So within this picture, I tried to show the, let's say, 3 pillars of SAP Embrace. On the upper side, I will highlight that one. You have the lift scenario, which is basically lift and shift. So you take your SAP systems and put them into the infrastructure as a service offering of Microsoft. This is now not a focus of our talk today. You also have, from a software engineering perspective, 2 further options now. You can reshape your system, enhancing your processes with intelligence and automation, bringing together SAP and Microsoft's offering, like integrating Office with SAP and supporting the business workflow of your clerks. And last but not least, if you create new add-ons, you now have really a full bucket of options that you can use in order to make that reality, like Azure Functions. And this lower part, the create part, will be the focus of my talk. I did some scenario where I just plugged together some serverless extensions, some serverless offerings of Microsoft Azure in order to extend my SAP system. And that's depicted here. There's also a blog available on that. So what I did was I just put some data out of S4, put that in a message queue, then used the serverless offering Azure Functions in order to connect to an S4 system, making use of the SAP Cloud SDK, and then put another message in another queue and kick off a logic app, which is another kind of serverless offering, and send out an email. So this was more or less a technical proof of concept in order to show how easy it is already today to build those side-by-side extensions. And I decided to go serverless because I think that's what comes closest to cloud native development. So you only pay for what you use. You have a very fine-grained way of building your business logic. You can focus on your business logic. All the rest is happening behind the curtains. So I think that's, from my perspective, the way to go when you start extending a system. And what we will focus now today on is the functions part. So this part here. Azure Functions are the function as a service offering of Microsoft that live on Microsoft Azure, so you can deploy them there, and you can then make your calls like you would do with any function as a service offering. Having said that, Microsoft or Azure Functions are open source. They have been open source right from the start, so there is no need to deploy them to Microsoft Azure if you don't like to. You can also deploy them to any Kubernetes cluster. You can even deploy them to Google Cloud Run if you would to. Now what I did within this function here, within this scenario, I made a function that did 2 calls to the backend system in order to find out something about the dunning level of a customer, and then if the dunning level exceeded some stage, made a second call in order to get additional information. For that I used the SAP Cloud SDK, and I bundled all that stuff within one function. That's okay for a proof of concept, but within this talk I will show you that there are better ways. But before I show you the better ways, I want to give you some insight into Azure Functions. So how are they basically structured? So let's move to the code. What I have here is now a typical Azure Function project. So you have a lot of configuration files here. You have, for example, the package.json that you're probably familiar with, where you have quite some information about how to start it, what are the dependencies. You have a host.json that is quite empty here, which is kind of the global configuration of your function. And then what you have is the function itself, which is in this folder. And the function itself is consisting of 2 parts. That's the function.json file, which is the configuration of your function, and the index.ts, I made it in TypeScript, or index.js if you do it in JavaScript, file which contains the logic. The function.json file basically tells your runtime how to interact with the function. So what event triggers the function, which is kind of a very special binding. It's depicted here. So we have the input binding, the direction in, which is a service bus trigger, which triggers off or kicks off the function and gives in the data that is received by that input binding. There are 2 different types of input bindings. This is the trigger binding, which kicks off the function. You can also use an input binding in order to read some data right from the start, like some configuration data from a database. And next, you have the so-called output binding. So you can use that in order to bind to a function to an output channel. So for example, within this case, to create a message in a service bus. And there is not much you have to do in order to now connect to the service bus, because all the magic is happening behind the scenes. So that's kind of the configuration. So you have a binding that tells you when the function will be kicked off and what data is imported. And you can also enhance that or enrich that with an output binding that you can use in order to propagate information. The code itself is, well, functions. If you look at function as a service, it's basically always the same. What you have here, and I will put that away, is you have an Azure function, which is an asynchronous function, which gets in some context, and you can do some logging here. And then what you see here is I call a function in order to get the dunning information, a local function, which is really a TypeScript function. And depending on the information, I do a second call here. And within these calls, if we scroll down here, I make use of the SAP Cloud SDK in order to interact with the system, the S4 system, in order to get the data in a handy format. And what you can see here is I now build my output message, and I simply put that into the binding that we defined within the configuration, and that's all you have to do. So within the logic of the function, you do not have to clutter all this stuff with information about how to make up the connection, how to interact with the message queue or with a database or whatsoever. You just put it into the context binding, and everything else happens behind the curtains, which is quite comfortable, I would say. So that's kind of the function that I built and that I've shown you before, which is purely technical proof of concept. You see, it's already quite lengthy, not that much fun. So let's go on. Now there are some points that you have to think about when you use serverless. There are some principles and there are some best practices that you can see as trade-off or as drawbacks when you work with functions as a service. So first of all, functions must be stateless. Why? Because the scaling is done for you. So you have an auto scaling, it scales out depending on the demand, and it also embraces full elasticity. So it also scales in again, scaling down to 0, because you only pay for what you use, and if your function is not called, you pay nothing. That's why functions must be stateless, because you simply do not know when will my function be killed, when will another function be invoked, and so on. What's also important is functions must not call other functions. That's something that you should not do, because this way you kind of overcome the pay-as-you-go stuff. So when one function calls another function, the outer function waits until the other function completes, and so you pay for something that adds no value. And what is kind of a best practice is functions should do only one thing and should that one thing well. So when we now move on from my kind of technical proof of concept that's far away from reality, the question arises when it comes to business software: how do we model workflows in a function as a service world? If we respect all these principles, the stateless we have to respect, and also the best practices. Well, a typical pattern that you see is this function chaining pattern. Backing off my laser pointer again. In order to achieve kind of a sequence of executions, what you would do is you would execute a function, which will then put something into a database or into a message queue or into a message queue and a database, depending on what you want to do, and then a second function will be called and then a third function. You can do that, but there are some problems or some points you have to consider. If you do that, well, it's perfectly loosely coupled, which is good, but the relation between the functions is not clear. So you do not see how this orchestration works. All the queues that you have to put in are basically a necessary evil. You have to do them because you don't want to call a function from another function. If you want to have some context, some state that is transferred between the function, you have to store it explicitly in a database. Well, and unnecessary to say, if you have such a very loosely coupled distributed system, the error handling becomes really complex. And well, this is something that you don't want to do. And now the question is, well, I told you within the last 15 minutes that Azure Functions is cool and you can do a lot with serverless. And now I come up with the first real world problem, which is a sequence of execution steps. And I tell you there are a lot of problems. That's why I want to introduce you to an extension of the Azure Functions framework that's called Durable Functions. It's also open source, and it preserves the local state via event sourcing. So all this stuff that I shown you on the slide before is something that you don't have to care about. all the heavy work happens behind the curtains. So you can again focus on your business logic, and in addition to that, the Durable Function Framework offers you quite some nice additional features that help you to solve your work in front of the curtain, kind of. So how do durable functions work? So let's take a little pseudocode where we say we have kind of an orchestrator that orchestrates the work, and we have activities that do the work. And what we want to do is a very, very simple sequence of steps. So what we do is we call an activity, which is F1, and we await the result. And we take that result and put it into a function F2, which will then return another result. And then we call a third function or a third activity, which is F3, and put in the result of the second function, and then everything is done. So that's kind of the sequence that I've shown you before, and that's kind of what we would like to see within our code, because this makes it quite transparent what happens. Now, how does Azure Durable Functions solve that? So what we have here is three things. We have a trigger, which kicks off the orchestration, which tells the function, hey, I have something to do for you. We have an orchestrator who, as the name intends, orchestrates the work. And we have activities, which are the functions that do the work. So let's play this little thing through, and a trigger kicks off your function and puts a message into your queue. And this message is then picked up by the orchestrator, and the orchestrator now tells the first activity, hey, I have something to do, puts it in a kind of a work basket, and then the orchestrator sets itself to sleep. So I modeled that with this gray coloring. So now this outer function is no longer working, so you do not pay for it. And the activity is now awaking, picking up the message, doing the things it has to do, telling the orchestrator, hey, I'm done, going to sleep again, and then the orchestrator, or the framework around the orchestrator, wakes up the orchestrator and tells him, hey, go on with your work, there is something to do. The orchestrator checks the queue, looks into it, hey, number 1 is done, so I now wake up number 2. And then the second activity function is called, and the orchestrator always goes to sleep, and the activity wakes up, the activity goes to sleep, the orchestrator wakes up, until all the tasks are done, and you can pick them up after that execution. It's all asynchronous, so you trigger the orchestrator, you get several URLs back where you can queue or query the status of your orchestration, where you can stop the orchestration or restart it, whatever you want to do. So that's all the magic that happens behind the curtains. So concerning all this message handling and the event sourcing, you do not have to care about that. So basically putting that in one picture is something like that. So durable functions are like an orchestration trigger, which then triggers the events, the activities, and all the activities do their work. Now, what's another cool thing, what I absolutely like about Azure Functions is the development experience. And why? Because you can do most of the stuff locally. Here I have written down the prerequisites that you need in order to execute all that stuff locally. So you need the Azure Functions runtime that you can download. Then you have to install Durable Functions, which are an add-on, which is a simple npm install. And in order to execute Durable Functions, you have to have some further stuff. You need to store the state, so you need to have some database somewhere, which is the SQL Server Express database that you can use there. It's a one-click installer, so it's not installing on HANA Express with all the stuff around there, which takes you like forever. It's just installing, clicking, you're done. Then you have to have some linkage between the durable function extension and the database, which is this storage emulator, which emulates the storage for the Azure Functions runtime and the durable add-on in order to put the messages in. And if you want to have some insight into your database and what happens behind the scene, you can also install the Azure Storage Explorer, which is a tool in order to explore your storage within Microsoft Azure or locally. So you can also connect it to your local SQL Server or your local storage emulator, to be precise. If you want to take a closer look how you can install that, there is a link to a video that I made on that. It's super easy. I did it on a Windows machine. As far as I know, you can also do that on an Apple or a Mac, but I never tried that. I'm a Windows user, and well, if you use a Mac, try it out. There are, I think, Azure Read is the storage explorer. It's a community stuff, so I cannot say anything about the experience there. Okay, so let's start. What do we want to do first? So currently, our activity function is one activity function. There is no durable framework all around that, which does 2 calls to an S4 system using the SAP Cloud SDK. And what I want to do now is I want to decompose that. I want to model that sequence that I have. I want to have an orchestrator, call my first activity, call my second activity, and then return the result. So let's take a look into the code. First, what we have to do, we have to check out the right branch, which is durable function. Yep. So here we go. And now you see the setup of the project has changed because I have a lot more functions in there. The first one is the trigger function. So this is the one that is used in order to kick off your orchestration. When we take a look at the configuration, you will see we have some trigger input binding. So I will now trigger that with an HTTP trigger, not with a message trigger, just for the sake of the demo. You can see that within the binding, we can now also define some routing, which is then kicking off the right orchestrator function. So with one trigger, depending on the request that you send, you can trigger different orchestrators, and it returns some HTTP. And what's important is this one here. It's a binding that tells the Azure Function runtime that that's a durable client and it's allowed to kick off an orchestrator. The function itself is super easy, so there is no magic in there. What I do is I create a client for the durable function. I create a new instance of that one and, well, kick off the processing of the orchestrator. Next, we come to the orchestrator itself. So this is the guy that has that whip in its hand. So it orchestrates all the stuff. Here the binding is super simple. So we have now an input binding which tells the Azure Function runtime that we are dealing with an orchestration trigger. So this is the guy who kicks off the activities. So super easy here. And now when we take a look at the orchestration itself, it's much easier, much more transparent than to the stuff that I did before. So what I do here is I kick off the orchestrator, which is a generator function. So this is a construct that's available within JavaScript. And this orchestrator calls the first activity. It calls it by its name and hands over the data that's bound to the HTTP request that's handed into the orchestration and then into the activities. In order to get the Dunning level, it enriches the input binding by the dunning level, and then calls a second function which retrieves the additional data, and well, we then return the data. And the activities then do the work. So as I said before, we have two activities. I will now dive into one activity for the sake of time, because the second one is the same. We have here the configuration, which tells the runtime it's an activity trigger, and that's it. It's called by the orchestration, and it does its thing, mainly calling the S4 system using the SAP Cloud SDK, and then returning the data to the orchestrator function. The second one does the same, just fetching some more data, some detailed data at another endpoint of your S4 system. So now let's take a look how that can be executed. So what we will do start the function, which you can do because your runtime is completely local. You get some super nice ASCII graphic, and you see the runtime picks up 4 functions. That are all the ones that we've done. It exposes an endpoint and the methods that we defined within our function .json file, and host log is required, so I can now kick off the function. And what I will do is I will use a little add-on that you can install within Visual Studio Code, which allows you to define HTTP requests. So what I will do now, I will call or put a post request to my orchestrator and let him execute all the steps. So I will now send the request. And as I said before, it's an asynchronous request, so you get back a status query URI, you get an event post URI, a terminate, a rewind, and you can also purge all the history. And what we will do now, we will take that one, put it into a browser window, and let's see what happened. I'll make that a bit bigger. Yeah. So I have some input, that's the stuff that I put in, which was the business partner ID, the company ID, and the dunning area, and well, the function executed. I have some output here telling me that the dunning level is 1, and I enriched it now with the full name. So everything went through smoothly, that's cool. So let's take a look at what happened behind the scene. Here I have my storage explorer, and I attach that to my local development machine. I take a look at the tables, and we have now 2. This is the one that contains the instances of the durable functions, where we can see kind of the header data of the execution. So we have the input, we have the created time, the last updated time, the name of the orchestration that was executed, and we get the result. That's already quite good to know what happened. That's basically the output of the status call. And when we take a look at the history table, what we will see here, sorted by timestamp, is exactly what I showed you before. So what we have here is that we kicked off the execution, the orchestrator started, and then a task was scheduled, so which is the first activity. Then the orchestrator completed, set itself to sleep, was no longer executed, and the activity was working. An activity call said, hey, my task is completed, I have retrieved my dunning level, and set itself to sleep, and the orchestrator started again, scheduled the second task, laid itself to sleep. Second task was executed, adding this additional function about the full name of the customer, and says, okay, I'm done. The orchestration started, execution was completed, and the orchestrator completed its work, and everything is done. So this is kind of exactly the sequence and the game that is played in the background when these functions are executed. So I will close that stuff in order to not kind of mess up the history with a lot of data and which makes it difficult to read. I will now clear that storage emulator that you can see is completely running locally here, which basically takes away all the data. Before I do that, I will stop the function, because otherwise it will tell me a big error that it can no longer connect to it. So now everything is clear again, and we can restart. Okay, so what we have seen up to now, I will bring up my slides again. Switch. Okay, so what we've done up to now is we have now split up the execution to two functions that are executed in a sequence, and it's super easy. It's super transparent, this refactoring, so we now clearly can see what happens one of the other step. And now the question is, well, we are dealing with a non-cloud native system. So we're dealing with an ABAP system which might be down at some point in time, which might have issues at some point in time. Maybe the first call to it will not work, so maybe we should issue a second call, put in some retry logic, right? So what do we have to do? Do we have to put in a loop or something like that in order to make retries after a certain amount of time? What happens with the activity? What can we do there in order to accommodate this real life scenario? So let's take a look what we can do here. I will check out the next branch, which is the retry branch. Okay, so here we go. Let's take a look at the code. So as you can see, the structure of my project is still the same. I have two activities. I have my starter and I have my orchestration function. Now let's take a look what happened within the orchestrator function in order to model the retry. So what you have within your durable function runtime is you cannot only call activities, but as I mentioned before, durable function runtime or this framework, this add-on, helps you with your tasks. And it offers a method that's called call activity with retry. So what you do is you can put in some retry options like when should I do my first retry? How many attempts do you want to do? What should be the interval between my retries, my max interval, and so on and so forth. I put them all in some process environment, in some environment variables for this processing. And these options are handed over to the durable function framework. And again, the durable function framework does its work. So what we will do now, let's take a look if this works. So I will now make an HTTP request and we'll hand in some wrong data. And I have defined, I think, 3 retries. And so the system will retry 3 times, and if it's 3 times erroneous, it will give up. So what I did, again, I put in these REST calls. So before we can make them to the endpoint, we have to start up the function, which will now again initialize everything, put in your functions in the right place, and let's wait till the host log is required. Yep, here we go. So now we can invoke them. So we send this request, which is, first of all, we make the right request with the right data. So let's see that everything happens right. So it was accepted, which is good. I will take the URL, go here again, and let's see. Okay, everything is fine. Now let's see what happens if I put in wrong data. As you can see here, the Dunning area is filled with a number that is not valid. And I will now send this request. And it's accepted again. It will be executed several times. I will fetch once again the endpoint, call it, and ooh, there was an error. So something went wrong, which is what we expected because we handed over the wrong data. So let's take a look into the Storage Explorer. What happened behind the scenes? Again, we navigate to the instances. We should see now 2 instances. Yep. Which is this one, which was the write execution, feeding in the right input data, and this one was the one that came to an error. So let's take that partition key here, go to the history, and put in some query where I put in the partition key, which is anyway the right one, execute it. Okay, we sort it. And now let's take a look what happened here. We'll scroll over here. That was not clever. Execute it again. Sort it. Yep, here we go. So what happened here? The execution started, which is good. The orchestration started and the first task was scheduled, which ran into an error, which is not good. So this task failed and the orchestrator started again. What happened behind the curtains is a timer was kicked off, and this timer tells the orchestration when to resume the work. So after the interval that we defined before, another task was scheduled, the orchestrator did its job, and the task failed again. Once again, as we said, we did it. Oh, I think I did it 4 times, as I see here. Okay. The timer fired, orchestrator started again and kicked it off. So all this retry logic that I said before, that I've defined within the configuration, was executed, and you had to do nothing but change the call itself. So what we can do now is we stop the function, we clear everything, and we can do a little trick now. We can modify the code of our orchestrator, and as the function or the orchestrator is resumed after the first retry, we can do this, save it, and what happens here is when there is a replay, so when it's executed again, we simply overwrite the wrong input data with the right input data. So after the first retry, everything should be fine again. Let's make sure that everything is cleared out. Okay, so let's give it another try and call it with the wrong data. So we send the request. Perhaps we should start it first. Makes sense. So let's see. No, come on. Okay, here we go. So now we can send the request, and now we can send it successfully. At least we reach the endpoint. So now it's first called with the wrong data, and after it's resumed, it's called with the right data again. And this is something that we should see now within the storage emulator. So let's go in here. We should see now one instance that we called with the wrong data. And what we see now is we have started the orchestration, and the first task failed because we handed in the wrong data. The timer was created, the timer fired, and the orchestrator started again. A task was scheduled, and now the task was completed because we put in the right data, so no more retry logic necessary, and all the rest is fine. So we get back here the right data, which is cool. I think there is, well, a lot of work that you don't have to do, that you don't have to think about when you do that, which is, well, quite handy when you want to solve problems, right? Okay, so let's put things back to work. I don't want to have that. Yes, I want to discard that. So we are back in the original state. So what's next? What can we do more with all that stuff? So we have now handled the error case. Now let's think about another option. So we do not run into an error, but the system simply does not respond. So what we can do, we can wait until the function as a service ends its execution time, which is 5 to 10 minutes if you are on a consumption plan within Azure Functions. So after 10 minutes, the function will anyway be killed by the runtime, but I don't want to pay for that 10 minutes. I mean, if I do not get a response within a reasonable amount of time, I would like to abort the execution. So how can we do that, and how can the Azure Function and the Azure Durable Function framework helps us with modeling such a race condition? As you might already guess, retry timeout. There is something that can help us. So again, we focus on the orchestrator function. Now we need a bit more of stuff to do. What changed? So now what we do is we do not yield the first activity call like we did before. So we do not tell the framework to call it and wait till it's executed, but we kind of tell the framework, hey, please call this activity with the retry logic that we've implemented before. And then we, in addition, explicitly define a so-called timeout task. So we create a timer that is then used within the durable function framework. And what we then do is we tell the durable function framework, hey, we have some tasks that we handed over to you within these two calls. Now please execute them. And the first one that returns is the winner. And if the winner is the Dunning level task, well, then we say everything is fine. We cancel the timeout task and we return all that stuff. In the other case, we say, more timeout happened. Please throw an error and abort the execution. So this is now kind of what we saw before within the retry logic, modeled in addition by us explicitly. So if the task does not return, we will kill it explicitly, or we'll run into an error explicitly, because we don't want to wait forever. What I did in order to make that happen is within my the Dunning data function, it's this one, I introduced well, kind of a sleeper, and I defined here some timeout in milliseconds, which is lower than the time the function waits in order to cause the error to happen for the sake of the demo. So this is what will happen now. So I will kick off the call, I will kick off the timer and the call and tell the framework, hey, please tell me which one comes back first, and then I will react accordingly and we will run an error now. So let's see if we can do that. We kick off the function again. Waiting until everything is up and running. And when it is, we will issue a call with the right data, but we will enforce the timeout to kick in. So we send the request. We will take a look at the status. Oh, okay, so we ran into an error, although everything was fine. So let's take a look at our storage emulator, what happened behind the scenes. So we have here our instance, which was aborted. And if we take a look at the history, we will see now that the orchestrator started, the task was scheduled, and the timer created because we told the system to create the timer. And the orchestrator completed. Then, well, the task was executed, the timer was executed, but the timer fired before the task was finished. So now orchestration started and it aborted it because we implemented to raise an exception within the orchestrator. And so everything went the way as we expected it to go. Okay. So what you can see here is the log output. I did not go into detail before, but well, there is a lot of information that comes out. For example, here the error message, timeout during processing of OData call. So it's with storage emulator and with the logs you usually find your errors. Okay, let's clear all the stuff again. And let's take a look what we have left. What more can we do with our Azure Functions? I love PowerPoint. Okay, so what we have now done up to now is we have kind of split up our function. We have handled error cases, we have handled race conditions for a timeout. Now let's take a look at the scale out topic. So up to now we have just dealt with one state, which was intrinsic to the orchestration. But what happens if we have errors and everything scales out and the backend system will not work anymore, where you usually would use a circuit breaker in order to not hammer down your backend system all the time? And well, may I introduce you to a kind of new member of the durable function framework, which is called durable entity, which allows us to model explicitly a state that can be accessed over several functions, even if they scale out, which allows us to model a circuit breaker. So let's check out the right branch. Durable func circuit breaker. Here we go. So let's close that and let's take a look here. So what changed? We have all our folders with the functions and the orchestrator here, and we have one additional function here, which is the circuit breaker entity. It's a durable entity that contains the state and stores the state explicitly. It's defined as an entity trigger. So again, we know that that's the durable function. And here within the durable function, which is, well, debatable if that's nice or not, we define via the durable function entity a function that has some initial circuit breaker state that I've defined via an enum, which is closed. We record the errors and so on and so forth. And we allow the system to interact with this entity by signaling information. So we can record errors like we do here. We can reset it. We can get the current state. So if the circuit is closed or if it's open. And here is some very basic circuit breaker logic. So if a lot of errors occur in a certain window of time, I will open up the circuit breaker. In order to handle that, I have my orchestrator, which creates the circuit breaker entity when it's first kicked off, and then checks the state and well, does its thing. If the state is already open, it will no longer execute something, it will just raise an error in the board. In addition, I also have implemented that within the activity function. So whenever an error occurs here, the error is reported to the durable function that you can see here. So here I catch an error during the execution, I fetch the date, and I signal to the entity that an error happened. In addition, I also check within the activity if in the meantime the circuit breaker switched its state, so maybe another function was executed, and react accordingly. So we have cleaned up everything so far, I think. So we can now execute that scenario. Again, we do an npm run start. So what we will see now is we have now 5 functions loaded. I think that was a bit fast. So we have 5 functions loaded because we have in addition the durable entity that gets instantiated. The rest is basically the same. So there's nothing else happening. The application started and we can now issue some REST calls. So we can now, for example, send a request that's doing the right stuff. So what we will see here is it is accepted, and we can check if everything is working as expected. So we put that one in. And the runtime status is completed. What I'm wondering a bit is why it doesn't show up any information. So let's take a look here. Because I commented out the second part. Sorry, that was my fault. I didn't tell you that. So within the orchestrator, I basically just execute the first activity function, and I do not execute the second activity function. Yeah, so that's why that happens. Okay, now let's kick off some more calls and let's send them with the wrong data. So I will now send several requests, which will all run into errors. So now what is happening is we will see probably some errors coming up. Yeah, so that's what I expected. Because the circuit breaker is open now, no calls walk through to the endpoint. So complete chaos, mayhem. Let's take a look at the database. So we have now quite some more instances here, because these are all the ones that we kicked off, and we have one very special instance here, which is the circuit breaker. And what you can see here, it's 0, so it's open. It's defined in the enum. We have some counter here, we have some received from instances, and what you can see here now is that up to the point where we came up with the error. Some events were raised, which triggered the durable function in order to tell it, hey, something went completely wrong. And this caused the entity to open up the circuit. So that was the last thing I wanted you to show. Well, there was a lot of stuff that I told you, I would guess. So let's shortly resume. So with the new functionality within durable functions, the so-called durable entities, you are now even able to handle state across a scaled out function. So you are no longer slave to the internal handling of a state within Azure Functions, but you can also model that explicitly. All the stuff that I've shown you is available on GitHub, so you can dive into that if you want. And well, what did I show you on one slide? We have durable functions, we have Azure Functions, which are a great way to extend your SAP system in a serverless way. And this add-on of durable functions delivers you a lot of functionality that you can use in order to model real-life scenarios. It allows you really to model complex scenarios without losing the benefit of function as a service and without diving into super complex scenarios in case of error handling and so on, because it manages the state for you and helps you with some other things like timeouts as you've seen before. The entry barrier for the starting off, so if you want to do it, it's super low because you can do everything locally. And from my perspective, all that stuff really opens up a lot of new options in the context of side-by-side extensibility. And this is something that you can now use in a lot of new scenarios. So that's it from my side. I thank you very much for your attention. I think we have some more minutes to discuss some questions that you put into the chat. And if we run out of time, I'm there for certainly for some more minutes on Discord, and I'm happy to answer your questions. So let's go. Thank you very much.